In the words of Monty Python, and now for something completely different. My name is Mike Green. I am the Chief Technical Officer of the Arava Power Company. The Arava Power Company is the oldest and largest PV developer in Israel. We are on the receiving end of the APC table. In the interest of ensuring that this nascent PV industry develops strong and healthy, realizing the financial targets of investors, the Arava Power Company accepted the invitation of Dr. Arbiv, the Deputy Chief Scientist of the Ministry of Infrastructure, to join the International Energy Agency Working Committee Task 13 of the PV Power Systems, or PVPS. I was joined by Mr. Amit Zorkafri, one of the owners of Unirom Electronics, a forward-thinking PV contracting company with 20 years of experience previously in the field of power electronics. Brochures or flyers on this task are available at the Arava Power Company booth located in the Herod Pavilion. I invite you to visit the website of the IEA, pvps.org, to learn the activities of this important committee. Clicking on the Organization tab on the head page will take you to the tasks that are that have been undertaken by the PVPS. The tabs at the top of this page will show you the current tasks and a tab showing the completed tasks. The tasks still current are the first 8, 9, and 12 through 13. The first task is the exchange and dissemination of information from member countries on PV systems on a yearly basis. The staff at the Israel National Center for Solar Energy, near Sde Boker, looks after this task. Task 8 deals with the viability and effects of very large PV fields in remote areas. This task has produced 2 books available for sale in the open market. Professor Feynman from the Israel National Center for Solar Energy near Sde Boker contributed to this task. Task 9 deals with PV in developing countries, and Task 12 deals with the environmental aspects of PV. Task 14 is a new task dealing with the inevitable effects caused by large PV plants feeding into the electricity grid. The Israel Electrical Company has sent a delegate to join this research project. That leaves Task 13, another new task begun less than a year ago. From the brochure or flyer, I quote here, "Performance and reliability of photovoltaic systems. The overall objective of Task 13 is to improve the operation, reliability, and consequently the electrical and economic output of photovoltaic power systems and subsystems through providing a common platform whereby quality aspects are elaborated and exchanged amongst the stakeholders, and disseminating this knowledge to different market actors." Task 13 is divided into 4 subtasks, each with a number of sub-subtasks. I certainly won't define all of them now. If you're interested in more information as per the entire task, you can take a brochure from the Arava Power booth and be in touch with me. The first subtask is performance data acquisition from as many PV power plants as possible. The second subtask is analyzing this performance data from the first subtask. The third subtask is analyzing the testing methodology currently employed by testing laboratories the world over. And the last task is the dissemination of the work that we have done. Israel is undertaken to lead subtask number 1.3, failure analysis. Server hardware and software has been purchased. We are currently writing the data acquisition and database software, and we are testing the equations we wrote to normalize the data into a comparable format. That is the performance ratio. All collected data is anonymous, only locale is shown. The distilled and normalized data will be sent to the PR database in subtask 1.1. The overall concept of failure analysis is to collect as much data as possible from each system before, during, and after a failure, categorizing, analyzing, and eventually achieving an understanding of what causes failure and how we can catch failures by looking for identifiers in the data coming from the field. The data we collect is either hardware failure alarms from the field elements or a drop in performance of the system. The performance of the system is defined theoretically during the planning stages of the building process and verified or modified during the acceptance test procedure in the field when it is taken over by the owner from the contractor. This standard performance ratio is compared to the real-time performance ratio, which is achieved by reading kilowatt hours from the inverters and kilowatt from the sun radiation sensor, normalizing both to kilowatt hours per square meter, then removing the effect of the temperature on the performance by reading module temperature and multiplying by the temperature coefficient of that particular module or type of module. If the variance between the standard performance ratio from the acceptance test procedure and the real-time performance ratio at that particular time is greater than a certain threshold, we have a failure. All the data will be used for an international study on failure analysis to be undertaken by Dr. Alessandro Colli of Iraq in Italy. The Israeli data will be used for a local study that will attempt to find causes for failures and to derive good operating procedures from this knowledge. All those who donate their data to this project will have access to the entire database. In conclusion, I would like to relate to what I see as the contributions to the PV industry in Israel from this study. I believe that we will be able to encourage the changing of monitoring norms to allow for performance monitoring. I hope to establish acceptable criteria for maintenance levels based on the objective reading of solar radiation using sensor panels made of the PV material similar to that of the power modules. I believe that this research will allow us to achieve acceptable warranty terms after commissioning. The long-term contribution to the PV industry in Israel is in establishing design criteria based on facts from the field here and quicker troubleshooting and problem solving. You can get more information on this by contacting me, or you can go to the booth, and to find my contact information, you can go to the booth of Arava Power in the Herod Pavilion. Thank you.